Hi, everyone. Thanks for attending today's session. So we'll go over why knowledge graphs are great for AI and agentic AI, and we'll see how it makes your AI more trustworthy and explainable, right? So we'll go through that. So what's the agenda? We'll go through some of the AI challenges we have with enterprise data, understanding context engineering. Some of you already know some of that term. We'll go over what is context engineering and why knowledge graphs really help to build that context and make your data AI ready. I will not have time to go through a demo today because a lot of slides. But if you stop by a booth, I think it's 1212 booth number, we'll go through the demo, and you can also understand our new Aura agents and MCP servers and stuff like that. So let's go over some of the challenges we have, especially with the enterprise data, right? As you all know, AI is a great accelerant, right, for new experiences and processes. It really defines, to get new, drive innovation, reduce complexity, improve experiences, all of that to lower cost, grow revenue, manage risk. So there is definitely a lot of adoption with AI. But you'll be surprised to know that only 5% of the projects actually go into production. Right, 95% don't reach production. So this is the new report from MIT and Gartner's study where it shows that only 20% of the projects actually do a POC, and of that, only 5% go to production. So a lot of the survey that we surveyed, customers say that the data is not AI ready, right? So that's the reason why they don't go to production. The reason might be the data is in silos. There might be security constraints. There are a lot of regulations and stuff like that, right? So those are the main reasons. So we'll get into some of that. So here are some of the AI challenges around enterprise data, right? So we know there's hallucinations, obviously, but that's improving on the public internet data. But on the enterprise data, it still needs a lot of improvement. And AI really is like a black box, right, where enterprise don't really get you all the data to customers, and there's a lot of regulations and compliance around data, right? Those are the main reasons. And other big reason is the context, right? So you really don't have a structured or connected context-rich context that we can give to LLMs. We'll get into that a little bit, but those are the main reasons, right? So what we have done is we have bucketed that into three big buckets. There's a data organization problem where your data can live in many data sources, right? You can have data warehouses, lake houses, traditional relation databases, document stores, and so on. So AI really cannot access that information. So that's a challenge. The other is you might have different schemas, right? Schemas, data models, formats, structures. So you really cannot, AI cannot really understand, sometimes interpret that information. So that's another challenge. So those first two, it's easy to interpret. Like a lot of enterprises are actually working on that. The third one is a big challenge where scale of query diversity, right? So let me go a little deeper on that. Query diversity is a big problem where you ask a question to LLM, right? Now with the enterprise data, you have a lot of information, a lot of sources to gather, take information and query. So it's not one query. It's not like one question to one query, right? So you have a lot of queries to gather and then get to a solution. Let me give you an example, right? Let's take a supply chain optimization use case as a use case. And the question is, you want to find the best routes from point A to point B. You ask, that's your prompt, that's your question, right? But now you have to deal with a lot of data sources. You might have to get into ERP systems, your data warehouses, many of those sources. Now you start asking, digging deeper. Probably you want to say, I want to identify possible routes. I want to trace dependency chains. I want to ask the delays and the lead times. So you start asking those questions. So that basically, it's a lot of query. So now you're hitting it with a query diversity problem, right? So there are two ways to fix that. Either give a lot more context to the LLM so that it understands, or consolidate the data somehow so you have a simpler query, right? So that's exactly what we're trying to do. Graphs help you do that. It obviously boosts accuracy and improve explainability. And the reason why you're here for this talk is it actually allows you to get you more context and make the data AI ready, right? We'll get to that in a bit. So before that, let's understand what is context engineering. Some of you already know that term here. It's basically an evolution of prompt engineering, right? So by definition, it says that you just give enough information to the LLM so that it can get to the next stage or next step, right? So you want the right data right at the right time, at the right structure, so it knows what to do next. So why does it matter now? I mean, traditionally or even now, like what's happening is you expect one-shot LLM prompts, right? So you give an answer, you ask a question, you think that you'll give an answer. That's very straightforward. But that's not the case with enterprise data, right? You have like multiple data sources. It has to reason. So especially with agentic AI, it has to reason, it has to plan. You have multi-step actions. You probably call multiple tools. So it has to fetch data. All of that, right? So again, it comes back to the query. So it has to do multiple queries to get that information. So what we are saying is give enough context so it understands what to do next, right? So that's a basic idea. Again, that's a definition by Langchain as well. So what are some of the sources you have, right? So you have all the user interactions that you give to the LLMs. Now that can be your prompts, your feedback, and all the interactions you have with LLMs. It keeps the state and history, so that's also can be part of the context. It has a short-term, long-term memory within the models, so that can also be used. You have structured output, that is basically your APIs and data tools that you fetch data from, right? That is also part of the context. The other big thing is a RAG. So now you can actually retrieve information from your vector database or your GraphRAG, where you have a graph database like Neo4j, and that can be part of the context, right? So those are some of the sources. And this is the same view, but from a different angle, where you have human interactions, you have cognitive layer of the application, you have memory layer of the models, and you have data tools, right? The APIs. It's the same thing, but just laid out in a different view. So the other big thing which we need to consider, just because you have data, I cannot give all that information to the LLMs. It's going to hallucinate again, right? Because it has too much information just as a context. So what we are saying is there's something called as a minimal viable context. Just by the definition of context engineering, again, it's just the right information for the LLMs to do the next step, right? So we have to make sure you have higher signal-to-noise ratio, right, to get to the LLMs. So that's another concept, basically, with context engineering. So at the crux, that's what it is, right? You give the right information. Even if you have agentic models, agents should understand what to do next. So you need that context information. So why graphs? So before I dig in, hold on. So before I dig in, what is graph database itself? So let's understand a concept of knowledge graphs, right? So it's basically, by definition, it's a design pattern to organize and access connected data, right? You can have any connected data. Everything is connected, right? So let's say you have a supply chain, you have financial data, you have networking, access control. All of that is connected, right? So by definition, you can have a supply chain knowledge graph. You can have a financial knowledge graph. You can have any of the knowledge graphs, right? So now it has specific information around that, right? The way we store data is something called as a property graph model. Instead of tables and columns, we have nodes and relationships, right? So think of, again, coming back to the supply chain, think of a supplier and a raw materials, right? Supplier is a node, and raw materials is a node as well. supplier supplies raw materials, so supplies, it's a verb, that's a relationship. So that's how we store data. And within that information, you can store properties, right? I can say, hey, supplier supplies this raw materials, but what's the date it's supplied on? What's the lead time? What's the capacity? So those are the properties. Now that is the context that you can store inherently within the database, right? So that's a big difference. So I don't have to have joins and tables and to extract data. Everything is inherently stored, right? So think of this as another example, right? So you have supplier. So now I have supplier graph. I have a product graph. I have a consumer graph. So now all your business can be all connected in one view, right? So now it solves two problems. Like I was saying, you have the query diversity problem. It's simpler to query with graph databases because you have all the connected view. I can do a multi-hop query. I can do reasoning, all of that because everything is connected and inherently stored, right? The other big challenge which we solve by this is giving the right context, right? So now I can give a minimal context to the LLMs for that to do the next step, right? So that's the reason why we say it's a AI-ready data because so you have all the connections and context within the database. Again, it's the same thing. I'm not going to go through that again. So think of this as a left and right brain, right? So right brain is basically your language, reasoning, creativity, and then your left brain is basically your knowledge layer, right? So you have context enrichment. Together, obviously, you have more explainable AI. So that's the whole idea. Coming back to RAG, this is part of the context engineering, right? So you're trying to provide as much context as possible. That's the whole idea, right? So traditionally, what you have is you have a retriever where you retrieve information from a vector database, right? It can be NoSQL or vector database. With graph, it's basically you're replacing that with a graph database, and that's a GraphRAG. That's all, right? But what we have now is since we have the connected view of all the information, you have the context. Now I can provide a lot more richer context to the LLMs. So that's the whole idea with the GraphRAG, right? Now, an example would be going back to supply chain, the same question I asked before, right? What's the best route from point A to point B? With Graph, I don't have to dig deeper into ERP solutions, spreadsheets, dashboards, and all of that, right? I can just do a single query saying, what's the shortest path? That's a query. That's an algorithm I can use, and you get the answer. It's as simple as that, right? So that makes it much easier. Also, you have other information that you can retrieve, right? You can do pattern matching, path finding. You have community-driven algorithms that you can retrieve from the graph databases. So it gives you an added benefit of using a graph database, right? So again, just to hit on the architecture here, so you have a data platform that can be, since we're in the AWS conference, it can be anything, right? Aurora, Redshift, S3 buckets, and whatnot. You have LLM, and knowledge graph can sit in between that as a context layer or a knowledge layer, right? So a lot of companies, what they do is they project the data from your traditional data platforms into knowledge graph. You don't have to project everything. You can just project part of the data there where you want to run algorithms or where you need the context from. And that can act as a context to LLMs. So a lot of companies are doing that. That just gives you an idea of how you want to use knowledge graphs. And also the knowledge graphs lead to more accuracy. And this is not we saying it. This is the public report, which you can access. They have run a study where they run knowledge graphs against NoSQL and SQL databases, and they've found that the accuracy is 3x more accurate in terms of responses they get from LLMs. So just to level set, right, why is that? Let's go to the semantics of it, right? Let's say you have a very simple example of apples and oranges. On the left, you can query, right? That's how it's stored. I don't have a vector representation. That's how it's stored in the graph database. On the right, it's a vector database. It's a vector embedding. So that's how you store the information, right? To do a search, you probably do a Euclidean or a cosine similarity search. On the left, on the graph database, it's very easy. You can just query, right? You can do a lot more with it, like pattern matching, path finding, and a lot of those things with the graph database. And imagine now that you have just one information now, right? So let's say you have supplier graph, product graph, consumer graph, all of that information. Now you can really analyze the data. You can do a lot more with it. Not only giving the context to LLMs, but you can do a lot more with it, right? So in essence, that's the advantage of using a graph database. So really, this is my last slide. Really, graphs go beyond GraphRAG, right? So you can, like I was mentioning, you have context engineering where you give the right level of context. It allows you to do that because it has all the information stored within the graph database, right? Also, when you're interacting, all the user interactions you have with LLMs, you can store that as context as well, right? Within the RAG architecture, you can go, like after the response, you have all the interactions, you can store that as context. You can probably store that as a property or relationships or nodes within the graph database. So you have that as a memory, right? You can use that as a context as well. Beyond that, you can obviously visualize it. The other thing is, which we didn't talk about, is a cipher query. It's a GQL query, just like a SQL. You have a GQL, it's a query, graph query language. Using that, you can do a lot of things like pattern matching, path finding, and so on. So that really allows you to visualize and explore data even further. I think that's all I had. And if you have any questions, we have booth 1212, and then we can probably go through demo. I didn't have time for the demo. I had a demo, but I didn't have time. But if you can come to our booth, we'll go through demo. We also have Aura agents and other MCP service as well. Thanks for coming.